Hello, so in this video I'm going to be showing how I graph the cosecant function. Now the way I'm going to do this is I'm going to try and use the characteristics of the sine function to graph the cosecant function, because hopefully you do remember in grade 11 that the cosecant function is basically just the reciprocal of the sine function. So cosecant x is equal to 1 over sine x, right? So here I drew two periods for the sine x graph. So this we already know. So basically, as you can see here, we start from -2 and we go all the way to 2 pi. Sorry, but we start from -2 pi and we go to 2 pi. And here is where I'm going to draw or graph the cosecant graph, okay? Now I am going to add more to it, just I figured it's a lot of writing and I don't want to waste too much of your time. So the first thing I want to mention is, hopefully you've realized by now that whenever we have an x-intercept on the sine x graph, there's going to be a vertical asymptote for that same point on a cosecant graph. And this is because cosecant is equal to 1 over sine, right? So for example, if we plug in pi for sine, right, we get 0 here. And if we plug in 2 pi for sine, so we do sine 2 pi, we also get 0 as shown by the graph, right? But if sine x is equal to 0 at pi and at 2 pi, that's basically meaning we're doing 1 over 0, and 1 over 0 is undefined. So therefore, on the cosecant graph, we're going to have a vertical asymptote at an x-intercept. So hopefully that makes sense. So as you can see here we're at 0 for the sine graph, right? And here we have vertical asymptote at -2 pi, right? Here at -pi, we're at 0 again, right? We're on the x-axis. So here on the cosecant graph, we're at -pi, and so on and so on, okay? So now I'm just going to draw a few more things, and then I'll be back. Okay, so to start off, I'm only going to be looking at this interval here. So from 0 to pi here. And then once we're able to graph the cosecant function in this interval, it should be easier to graph the rest of the function in the other intervals. Okay, so if we're going to look at this interval here, that means we're going to be looking at the same interval on the sine graph. Okay, and I'm just writing this out again to remind you that cosecant x is equal to 1 over sine x. Don't worry about the 0 and 1 for now. I'm going to talk about it actually right now. So basically, if you look on the sine graph, right, and you'll notice we're looking at the interval between 0 and pi, right? You'll notice that the y-coordinates, they only move between 0 and 1, right? They don't go below 0 and they don't go above 1 between 0 and pi. They're only moving between 0 and 1. So that's why I'm saying sine of x is greater than or equal to 0 or less than or equal to 1. Because in this interval, the points only move between 0 and 1, okay? So hopefully, now, it should make more sense of what I'm going to do now. So as you can see here, if sine is equal to 0, right? If it can equal 0, 1 over 0, that's undefined, right? And that makes sense because I forgot to mention this earlier, but if you do remember, if you plug in a 0 for x, if you plug in 0 for x here, sine of 0 is just 0. So since it's 0 on the sine graph, that also means there's going to be a vertical asymptote at 0 on the cosecant graph. Just I didn't draw a line there because there already is a line because of the x-axis. So there already is a vertical asymptote here. So this doesn't work. Well, this doesn't work to plot a point, but hopefully you do realize that if we plug in like a number that's really close to 0, like for example, let's say we have 1 over 0.00001, right? Well, if you plug this into your calculator, I don't know the exact number, but you're going to get a pretty big number, right? And what I'm trying to show is on the sine graph, right? If we plug in this value over here, the 0.0001, that's like really close to 0 on the y-axis on the sine graph, right? But since cosecant, since it's the reciprocal of the sine graph, that's the same thing as saying 1 over this really long decimal number. And when you plug this into your calculator, you're going to get a really big number. So if you're going to get a really big number, that means it's going to go to infinity, right? Because you can just keep adding these zeros on forever. You can keep saying, you can add like 0.10 zeros, 1, and the number is just going to keep getting bigger. So as you get closer to 0 for a cosecant graph, the graph's just going to go to infinity. It's just going to keep going higher. So let's say 0.0001 is like maybe over here on the sine graph and over here, right? Well, on the cosecant graph, if it's just going to keep getting bigger, the points are maybe let's say, perhaps they are, okay, the points are maybe perhaps here and here, right? Now this is not the scale, they would be obviously like way higher, just no room, no space, right? So now that we know where the points are that are close to 0, what about if we plug in the 1, right? Because sine x can equal 1 still, right? Well, hopefully you realize that we can actually plug in, if we plug in 1 for sine x, right? 1 divided by 1, that's just equal to 1. So on the cosecant graph, that's just going to equal 1. So at pi over 2 on the sine graph, we're at 1. So at pi over 2 on the cosecant graph, we're also at 1. So we can plot a point of 1. Okay, so it might be hard to see here, but this is 1, right? Because as I said earlier, pi to 1. So on the cosecant, so if we plug in 1 here, we also get 1. So pi to 1 on the cosecant graph. So there are points here, here, and here. Now, hopefully you do realize that 1 is going to be the minimum point on the cosecant graph, because as proven earlier, if you plug in a number less than 1, right, since cosecant is the reciprocal of sine, you're just going to get a number that's bigger than 1, right? So since this is the minimum, we can actually draw the graph now. If this is the minimum and these 2 points are just going to go to infinity, you can just do this. Right, so it's going to look something like that. And of course, the graph cannot touch the vertical asymptotes, right? There is a vertical asymptote at 0, just that I didn't draw it. So yeah, this is what the cosecant graph looks like in this interval. So basically, the graph here is going to positive infinity, okay? So now that we've graphed the cosecant graph in this interval, it's easier. It's a little easier now to graph the rest of the graph in the other intervals. Okay. Now, one thing I do want to note. This is important. When I was graphing in between 0 and pi, right? If you look here, the points on the sine graph between 0 and pi, they're positive. Okay. But if you look between 0 and negative pi, the points are negative. Okay. So basically, all you need to know is, since the points are negative between 0 and negative pi on the sine graph, this is just going to get flipped over in this interval between 0 and negative pi, right? And the truth is that you can use this method again, right? If you want. You don't have to, but you can if you want. So, all right. Now, so if you want, you can just use common sense, and when the points are negative on the sine graph, you can just plot this function in the same interval, but just flip it when the points are negative. But if you want to see again, you can use the same method I did to graph this, except the only difference is if we're looking between 0 and negative pi, right? Since the points are negative here, notice though how between 0 and negative pi on the sine graph, the points are only moving between 0 and negative 1. Okay, so our interval here for sine must be less than or equal to 0, and it must be greater than or equal to negative 1, right? And now it's the same thing, right? If you were to plug in 0 for sine, if you were to plug in 0 for x, you get sine of 0 is just 0, 1 over 0, that's undefined, right? So at 0, we have a vertical asymptote, I already talked about that. And if you were to plug in, since the end of the interval here is negative 1, right? 1 over negative 1, that's just negative 1. So since on this graph at negative pi over 2, we're at negative 1, right? We're also going to be at negative 1 on the cosecant graph at negative pi over 2, right? And now we can do the same thing. So we know that 1 over 0, that's just undefined. What if we plug in a number that's very close to 0, right? So let's say we plug in 1 over negative 0.0001, right? We have to plug in negative because we're below 0 between 0 and negative pi. Well, if you plug this into your calculator, you're going to get a really technically small negative number. You're going to get like negative 10,000, something like that. So my point is if you plug in a number that's really close to 0 between 0 and negative pi, you're going to get a really small number technically. So the graph's going to go to negative infinity, right? Because here, negative 0.001 on this graph can mean like here, maybe, or here, right? So when you plug this into your calculator, negative 0.0001 is here on the sine graph, but since this is the reciprocal, as proven here, when you perform this calculation, you're going to get a really small number. The graph's going to go to negative infinity. So if you plug this into your calculator, you're going to get like negative 10,000 or something. So for these 2 points on the sine graph, we can plot points on the cosecant graph, maybe here and here. And basically what I'm trying to show is that the graph now is going to go to negative infinity instead of positive infinity. And again, notice how instead of this being a minimum point, this is a maximum point now, right, at negative 1. Because if you plug in a number that is greater than negative 1, you're just going to get a smaller number. So this is what the graph's going to look like. Okay, and technically, I know this is going a little bit into this line here, but this is supposed to be a vertical asymptote. Okay, so the graph here does not touch the this line here because there's a vertical asymptote, and it doesn't touch this vertical asymptote. Okay, so as you can see here, I use the same method to graph the cosecant function in this interval. But as you can see here, you can just flip this if you want to graph it here because the points are negative on the sine graph, right? And now, if you notice, here between negative pi and negative 2 pi, the points on the sine graph, they're positive, just like they were between 0 and pi. So now we just know the graph here is going to look the same as here, right? At negative 3 pi over 2, we're going to be at 1, like here. Because it's also like that here, so we can do this. Okay. And finally, between pi and 2 pi, right? The points are negative on the sine graph, just like they were between negative pi and 0. And since we already know what the cosecant graph looks like between negative pi and 0, it's going to look the same between pi and 2 pi. Okay, so basically, this whole thing here is the cosecant graph. So basically, I just wanted to show how I think of it when I try to graph the cosecant graph, which is the reciprocal of sine, by using the sine graph. So hopefully my explanation was clear. But yeah, this is what it looks like.